It's Wednesday, the 3rd of April 2024. These are the science and space headlines we're following on Talkin Science. 49 new galaxies found in under 3 hours. SmartSat's satellite survives rigorous testing at Mt Stromlo, and unlocking supernova stardust secrets. Welcome to Lot 14 here in Adelaide. It's the hub for all things Australian space industry. Not only is the government agency behind me, but also SmartSat, Equatorial Launch, Inovor, and so many others. The Stone and Chalk building beside me, that's where all the startups are living at the moment. Very, very exciting. We'll be back for the Dr. Andy Thomas Space Forum in July at the Convention Centre up the road. Plus, we'll have a deeper dive here then. Right now, Trekzone podcasting has been stuck on hold thanks to the production company needing my undivided attention. But since I was in town for more work, I thought I'd bring you the past month of headlines from here at this critical meeting place for Australian space endeavours. First up, 49 new galaxies have been found in under 3 hours by an international team of astronomers using the Meerkat radio telescope in South Africa. Led by Dr. Marcin Glowacki from the Curtin University node of the International Centre for Radio Astronomy Research in Western Australia, the study aimed to understand star-forming gases in a single radio galaxy. He joins me now. Dr. Glowacki, welcome. Your initial search didn't turn up what you were looking for. Instead, you found something bigger.
Yes, we were looking for the star-forming gas, hydrogen gas, in one particular galaxy. We were trying to investigate how this galaxy is interacting with its gas. And we didn't find the gas there, which is fine. This happens in astronomy. But when I looked at the data that came from the Meerkat telescope, which is one of the square kilometer array pathfinder telescopes in South Africa, we found 49 detections of gas in other galaxies, which had never been seen before in this way. And this was done with less than a 3-hour observation with this new telescope. So to find 49 in one shot, which we weren't trying to find in the first place, was quite staggering.
Well, this finding proves how critical Meerkat and other similar radio telescopes are, doesn't it?
Yeah, so these are the new generation radio telescopes. They're more sensitive than ever before. So Meerkat is a fantastic instrument made up of 64 different antennas that are working together. In Australia, we also have ASCAP, which is a 36 antenna dish, which is less sensitive than Meerkat, but it has a wider field of view. So it's good for survey science, while Meerkat is good for getting really deep observations of particular galaxies. Both of these telescopes are pathfinders for the Square Kilometre Array, which is the next generation currently under construction in both countries, South Africa and Australia. So the fact that Meerkat can already detect 49 galaxies in a few hours, just by accidents, you could say, it really bodes well for how much amazing science the Square Kilometre Array will do within the next decade.
3 of these 49 are directly connected by their gas. What's happening?
So with these 3 galaxies, you have a much larger galaxy, and the other 2 are connected in their gas. So when you look at the optical image, they look very distinct. They're quite separated. But gas extends further out. It envelops the halo that the galaxy sits in. And so here what we see is that gas is being stolen from the 2 companions to the larger galaxy. It's taking the gas away, and it's using this gas to form new stars. In fact, it's forming more than 7 stars a year in solar masses, which is quite high a rate. So this is informing us on how galaxies can evolve, how it can strip other galaxies or even merge with them to form new reservoirs of gas that will then start new cases of star formation.
And I believe more gas-rich galaxies have been discovered by you and summer student Jasmine White.
Yes. So we realized if we had one observation with Meerkat that we would find nearly 50 galaxies. We have other observations that we've been working with that, again, were focused on 1 or 2 galaxies in the center of the pointing, but again, we might find some other galaxies. So Jasmine White was a ICRA summer student. ICRA is the International Center for Radio Astronomy Research. This is a 10-week program where students can learn about astronomy and do some science. So she was working with myself and Karen Lee Waddell, and she had one of her tasks was to look at other data sets we had from Meerkat and see if she could find any more galaxies. And across 3 different observations, she found another 85 galaxies, and most of those were also brand new. Not every single one, but again, we're averaging 20 to 30 new galaxies with each observation. So Meerkat is fantastic, and it's not just a fluke. It is a sort of unlikely to have found 49 in one shot. We haven't beaten that record yet. but it's fantastic for finding more galaxies.
The new galaxies have been informally nicknamed the 49ers, a reference to the 1849 California gold rush. Dr. Glowacki views the 49 new galaxies as valuable as gold nuggets in our night sky. Many galaxies are near each other, forming galaxy groups, with several identified in one observation. South Australian satellite Kanyini has achieved another key milestone with the successful completion of its environmental stress screening ahead of the satellite's mid-2024 launch. Project Director Peter Nikolov from SmartSat is joining me from inside the Space Discovery Centre. Peter, welcome to Trekzone. Let's start with what the Kanyini mission is.
Well, Kanyini was actually an additional initiative from the South Australian Government, so we got extra funding into SmartSat, and their main mission was to build spaceflight heritage for the local industry, so give our companies the opportunity to build an actual spacecraft and put it into orbit and operate it, which is critical for future needs.
And in the past month, there's been a significant milestone for the mission.
Yeah, no, we've just got through our flight readiness review, which is really exciting, so we're just about to pack it up within the next 3 weeks and send it off to the US for a launch on the SpaceX Transporter 11 mission out of California. But leading up to that was probably our biggest test element, where we actually put it through the chamber, the Space Environmental Testing Chambers at Mt Stromlo in Canberra. So it went through the full vacuum, thermal cycles and vibration. So passing that was a big relief for the team.
How important is Lot 14 to enabling space manufacturing right here in South Australia?
Oh, it's invaluable. When you're building complex systems, having the teams, you can just wander over, speak to the payload operators and just sort out issues and challenges as you go through the design. So Myriota are providing an Internet of Things payload for Kanyini. We've got a European payload for a hyperspectral sensor, which is quite sophisticated, up to 50 bands of light, which we can look at, which is perfect for when you're looking at vegetation and water and all sorts of other areas there. But it's also got an AI processing capability, so we can be able to process some of the data in orbit, because the sheer volume makes it just about impossible to download everything back to Earth. So that's super exciting. But Inovor Technologies basically are building a bus, the part that brings everything together for the payloads, runs the power management, runs the pointing and direction, thermal management. So no, it's fantastic to have the teams all here in one place.
So let's look ahead. What's next after Kanyini takes to orbit?
Well, I think the vision for SmartSat and the SA government is Kanyini 2, the next generation. This is quite a small satellite with, so you've got constraints with resolution and things like that. So this will help the government and SmartSat define what the next generation sensor would look like that would meet SA government needs.
Kanyini is heading to the US very soon to launch aboard a SpaceX rocket. Is it possible that Kanyini 2 could launch from Australia?
That's certainly a potential opportunity. We've got Gilmore Space, which you've probably been tracking in detail, who are building a class of launch vehicle that would be suitable of launching a Kanyini 2 class of spacecraft. So we're all very excited. I think there's a lot of good things come out of Gilmore in the next 12 months. So yeah, we'll just wait and see. But we've also, in Australia, we've got a number of potential launch sites available. We've got one down here in South Australia, in Southern Launch, down at Port Lincoln. They've got an inland test range out at Ceduna to do suborbital testing of spacecraft and systems. You probably noticed a few years ago, you probably would have seen in the media the NASA launches out of Arnhem Land, equatorial launch, and Gilmore's got their own, obviously, launch area as well, which they're developing. So with all those things coming together, we're hoping to have some sovereign launch capability in the not too distant future.
What's it like to have someone like SpaceX as a launch provider?
One of the important things is the cost effectiveness. Traditionally, if you tried to launch something on the old generation tip rockets, it would have been just prohibitive for smaller organisations like ourselves to launch spacecraft. So the advantage of SpaceX is the cost, but also their launch tempo. You probably every 6 months you'd probably have an opportunity to launch on one of their launch vehicles, and so that's invaluable.
Kanyini Project Director Peter Nikolov. NASA has chosen the first science instruments designed for astronauts to deploy on the surface of the Moon during Artemis 3. Once installed near the lunar south pole, the 3 instruments will collect valuable scientific data about the lunar environment, the lunar interior, and how to sustain a long-duration human presence on the moon. The instruments will address 3 Artemis science objectives: understanding planetary processes, understanding the character and origin of lunar pole volatiles, and investigating and mitigating exploration risks. They were specifically chosen because of their unique installation requirements that necessitate deployment by humans during moonwalks. All 3 payloads were selected for further development to fly on Artemis 3 that's targeted to launch in 2026. However, final manifesting decisions about the mission will be determined at a later date. An international research team have made incredibly detailed observations of the earliest merger of galaxies ever witnessed. They suggest stars developed much faster and more efficiently than we thought. They used the James Webb Space Telescope to observe the massive object as it was 510 million years after the Big Bang, making it around 13 billion years ago. The observations in the current paper show a galaxy consisting of several groups with 2 components in the main group and a long tail, suggesting an ongoing merger of 2 galaxies into a larger one. This and other observations using the JWST is causing astrophysicists to adjust their modelling of the early years of the universe, with these findings showing galaxies were able to accumulate mass so fast by merging. But it's not only the size of the galaxies and the speed with which they grew that surprised this international team. Lead author Dr. Kit Boyett writes in his paper how, for the first time, this describes the population of stars that make up the merging galaxies, another detail made possible by the James Webb Space Telescope. At least 1 in a dozen stars show evidence of planetary ingestion, according to a paper published in Nature. An international research team studied twin stars that should have identical composition, but in about 8% of cases they differ, perplexing astronomers. Led by Astro3D researchers, the team has found that the difference is due to one of the twins devouring planets or planetary material. These findings have been made possible thanks to a large dataset collected with the 6.5 metre Magellan telescope and the European Southern Observatory's Very Large Telescope, both in Chile, and the 10 metre Keck telescope in Hawaii. The findings have wide-ranging implications for the study of the long-term evolution of planetary systems. For the first time, the super-fast speeds of a neutron star's powerful jets have been recorded by CSIRO's Australia Telescope Compact Array and the European Space Agency's Integral Observatory. The research has been published in Nature. Neutron stars, like black holes, have huge gravitational pulls. When pulling matter from a nearby star, their extreme environments cause the occasional thermonuclear explosion and constant jets of matter shooting into space. Not much is known about these jets, including their composition or their speed. But these latest results have revealed that the thermonuclear explosions detected by Integral pushed gas into these jets. The jets were then tracked with ACTA, allowing their speed to be recorded. Professor James Miller-Jones from the Curtin University node of the International Centre for Radio Astronomy Research in Perth was one of the project researchers. He said it's typically hard to measure the speed of a jet, but discovering that they're enhanced after every thermonuclear explosion provides a new way of measuring their speeds. Curtin University-led research has discovered a rare dust particle trapped in an ancient extraterrestrial meteorite that was formed by a star other than our Sun. The discovery was made using a technique called atom probe tomography, which revealed the particle had a ratio of magnesium isotopes distinct from anything in our solar system. The discovery was made by lead author Dr. Nicole Neville and colleagues during her PhD studies at Curtin, now working at the Lunar and Planetary Science Institute in collaboration with NASA's Johnson Space Center. Clues that these particles, known as pre-solar grains, are relics from other stars are found by analysing the different types of elements inside them. Using atom probe tomography, Dr. Neville analysed the particle and reconstructed the chemistry on an atomic scale, accessing the hidden information within. Dr. Neville said the results were literally off the charts. The most extreme magnesium isotope ratio from previous studies of pre-solar grains was about 1,200. The grains in their study has a value of 3,025, the highest ever discovered. Well, Trekzone membership gets you in first releases and first details with a few tiers and a few options. You can help Australia's only science, space and science fiction podcast pick up the pace in 2024. The rain is coming down. I've got to go. Facebook, Instagram, TikTok and YouTube Shorts all have the podcast highlights, so find us where you are. I'll be back in Adelaide in July for the Space Forum, and hopefully we'll get to bring Talkin Science back here to Lot 14. Until then, this is Talkin Science for the 3rd of April, 2024.